The homework is due tomorrow, yes. So we got these 5 questions. Excuse me. All right. So we have our current homework assignment, 5 questions on conditional probability, what we've been talking about, this week, last week, working a lot of examples. I've got several more I'm going to go ahead and work with you, probably like a daily grade tomorrow. We are going to have our quiz today, but it's not going to have conditional probability on it. It's just our introduction. In fact, the homework assignment that you previously turned in, it's covering that material, like a tree diagram, lattice diagrams, things of that nature. Okay. So let's see here. What I want to go ahead and start with is one of the questions on the homework. Okay, so any one of the 5 you guys want to go ahead and work together, we will go ahead and do that, and then we'll just go ahead and get right into our quiz. So I'll give you a second to kind of confer between yourselves. 1, 2, 3, 4, or 5. I'm sorry. Math makes me feel better. Everybody having a good day? Yes. Okay. No? Kiana, why aren't you having a good day? Oh, I'm sorry to hear that. Okay. It'll get better. It'll get better. Tomorrow's Friday. Look at it, we're only a week out from our first vacation. Okay, so that's huge. Oh, in fact, speaking of, we're a week out from our first exam as well. Next Thursday, the 15th. We're going to go ahead and take care of it right before we go for Thanksgiving break. Okay. So that's all about probability.
I was going to suggest a problem.
Okay. So which one?
Number 3.
Number 3. All right. Eli is suggesting number 3. Is that one you guys like?
Okay.
Who said no?
All
right. Okay. Okay, so Araya would like to work 1, 2, 4, or 5.
How about 5?
Okay, 5?
Let's do 5.
Okay, so let's see, show of hands. How many people want 5? Why not? There we go. Okay. So let's see what we got here. So an urn contains 6 red and 9 blue cubes. A cube is drawn at random and not replaced. A second cube is then drawn. What's the probability that the second cube is blue given, okay, there's my keyword, that the first cube is going to be red? All right. So what can we do here? I would probably start with the tree diagram. I think that's an excellent way to start. So we're just going to draw a cube at random. So we only have red and blue. Okay, so we start with red. We start with blue. So what's the probability, Eli, of choosing a red first off? 6/15. Okay, so that would be what? Okay, 3/5, or 2/5, excuse me. Sorry. Okay, 2/5. Would everybody agree? All right. So we could go ahead and look at, the probability of the blue. That would be 9/15. But also, we realize that when we create the tree diagram, the total should always be 100 on those branches. So 3/5 right here. Now, very, very important. Are we replacing the cube or not? We are not replacing it. So this is going to change the probability as we go along. Okay, so if I choose a red, I then have the ability to choose either another red or a blue, and the same if I chose blue originally, red and blue. Okay, so take about 30 seconds, 45 seconds, write out the probabilities for each of those. Okay, remembering that every pair of branches has to add to 100%. Okay. Oh, somebody at the door. Hello, hey, Gabby. Right now we are just working on one problem from the homework. All right, so let's see for this very top branch right here. Now, if I've already chosen a red, then that means what? There's only 5 red left out of how many total? Okay, 14. So 5 14s. Would everybody agree? Okay. Now we can look at it. We haven't chosen a blue yet, so that would be 9 14s. You know, again, that sum to give me 1. Okay. What about if I chose a blue first? Then the probability of choosing a red would be 6 out of what? 14. So what would that be? Okay. 3 7. See, it would change it. Does that make sense? Okay. And then the other one should be what? Okay, 8 14s, which would be 4 7s. All right. Did everybody get the right probabilities? Okay. Yes, ma'am. I would encourage you to go ahead and simplify it. Yeah. Always want to simplify. All right. Any other questions? Hey. Oh, is it time to go? Okay. All right. Good luck with your interview. All right. Okay, so let me go ahead and set this up real fast. What's the probability that the second cube is blue? So let me write it out like this. We want the probability that the second is blue given that the first cube is red. Okay. And, you know, just to kind of make things go a little faster so I don't have to write the whole thing over and over again, we could just say this represents A, this represents B, or you could just write it out, you know, whatever you prefer. But kind of walk me through here. What's the formula for conditional probability? Hey.
The probability of the intersection of A and B over the probability of B.
There you go. We always divide by the probability of the given event. Okay, so just using A and B, this will be the probability of A intersecting B, if this thing will allow me to write, over the probability of B. Remember, always the probability of the given, the second part. Okay, so we've been talking a lot about how the branches are considered the intersections. If I add the probabilities at the end of the branches, those are considered my union. Okay, take another 30 seconds, write out what you believe these are. I need the probability of the intersection of A and B, and I need the probability of getting blue. Okay. So let's give you even 1 minute this time. And if you've already got it, fantastic. Is everybody about ready? Okay, so how would I find the intersection of getting the second drawn blue, given that the first cube is red? I want the intersection of those two. Eli, what do you think?
So don't you just need to find the branch where both instances happen?
That's exactly right, yeah.
So like where the first cube is red and the second one is blue.
Yeah. Okay. So we're going to follow along this branch right here. Okay. Okay. First one red, given that first one's red, given that the second one's going to be blue. I think I said that right. But that would be your intersection. So what do I do along that branch? We multiply those. So 2/5 times 9 14ths. Okay. That's going to end up to what?
0.26.
0.26. Well, let's leave it as a fraction for right now.
Oh, 9
Okay. Okay. Yes. So we should get 9 out of 35 because we could go ahead and simplify, before multiplying across. Now, just over the probability of pulling a blue. 3/5. Okay. So the probability of blue is 3/5. So I'm just going to go ahead and write it down here, give myself a little more room. So I'm going to take the 9/35. I'm going to divide by the 3/5.
There doesn't need to be 2/5 because we're dividing by the probability of B. No, the probability of the first one being red.
Oh, you're right. I took the B as blue. Sorry. Just think if you were paying attention. Obviously, you know you were. Okay. 2/5. La la la. Okay. That is right. I'm sorry. I saw the B, and that's why I wrote it out so I wouldn't have to do that, and I ended up doing it anyway. Okay. So I've got 9/35 divided by 2/5. And what do we do algebraically if you're dividing by a fraction?
Just flip the denominator.
Okay, there you go. We're going to multiply by the reciprocal. So 9/35 times, this is going to give me 5/2. All right, so we can simplify here. So it looks like I'm going to get what? 9/14.
Is it okay if we give decimals?
I'd say that's okay.
Okay.
I don't remember if I put decimals on my key or not, but had anybody worked this problem before and gotten the same answer?
I think so.
Okay, good. And see, this one works out nicely. You're looking for one event out of the entire situation, so the conditional probability formula is great, but kind of think about what this is saying. What's the probability that the second cube is going to be blue, given that the first cube is red? Remember, conditional probability is always based on the idea that some event has already occurred, right? Well, what was our answer? It was 9/14. So if I pulled a red first, the probability of that second one being blue did turn out to be 9/14. Did anybody happen to see that it was also right there on the branch? Okay, good. Does that make sense?
Oh.
Okay, so Eli, that makes sense now? Well, see, the formula still works, but if you happen to notice that, it won't work every time like that, but yeah, okay. It won't always be like that. It won't always be like that. So, I mean, it is a good thing we went through the formula. Okay. All right, so 5 is good. Yes, ma'am.
I have a question before, actually.
Okay, what's up?
So, like, I was drawing the diagram, but I guess I stopped focusing in my head about because I feel like both the problems are like not two individual trees.
Yes.
I would just
So they are independent. Yeah, so what did you say, Eli?
I would just use tree diagrams instead of the Venn diagrams. I think it.
I used a tree on this one as well.
No, I was saying that I used the tree for like I felt like I have Ernie as a tree and then Bert as a tree.
Oh, well, and it really doesn't matter which one you start with because, like you said, they're independent. It's like we were talking earlier today about rolling the die and flipping the coin. One isn't going to affect the outcome of the other. So how many total outcomes would there be if we're talking about Bert and, is it Ernie? It's so cute. I actually didn't come up with that, but it just works. Bert and Ernie either passing or failing this quiz.
Yes, there are 4 outcomes.
There are 4 possible outcomes. So whether Bert passes or fails, I mean, Ernie is going to pass or fail on his own, right? So who do you want to start with, Bert or Ernie?
Ernie.
Okay, Bert. Hey, I thought that was actually a pretty good impression. Yeah, okay. How to get to Sesame Street. What? Okay, who were we doing first? Ernie. Okay, I started singing the Sesame Street song. I got a little distracted there. Okay, so Ernie, this first set of branches is going to represent Ernie, so he's either going to pass or he's going to fail. There we go. And it says that the probability that Ernie passes is 0.65, so 65%. So what's the probability that he fails? 0.35. Now, independent of this, whether he does or not, and you can even start the diagram with Bert if you want to, but if Ernie passes, it's possible that Bert could fail or pass himself. Okay, let's do this one more time. Pass, fail. Okay, there we go. And again, this is in no way related to what's happening with Ernie, but Bert, he's going to pass with 80% probability. So I'm going to put the 0.8. So the probability that he fails is 0.2. So 0.8, 0.2. Okay. And I'll even go ahead and help you out with the very first one. Is everybody okay with how we got the diagram? Any questions on that? Okay. Well, now, what's the probability that both pass the quiz? Yeah. All I want to do is go along the branch where Ernie passes and then where Bert passes. Now, where'd you get the 0.52? There you go. You multiplied those probabilities. So 0.65 times 0.8 is my 0.52. And I believe that is correct. I want to say that's what I got. Okay. Oh, I'm feeling generous. And I like the fact that it's Bert and Ernie. Anyways, let's go do B. Only Ernie passes the quiz.
0.13.
Okay. And how'd you get that? Is that when a text message comes in or something?
Yeah.
Okay. All right. I'm trying to keep up. You know, my knowledge is on fleek. So. Okay. Technology is my bae. Do we still say these things?
Math is my day.
There we go. There we go. All right. All right. Anyways, well, what did you guys say? B. I got 0.13. Only Ernie passes. Okay. So there you go. You just go right along 0.65 times 0.2. All right. And D and E, those are the ones you're going to be looking at in terms of the conditional probability. All right. Hey, Emily.
So the conditional probability are the ones that you want to use.
The formula, yes.
Can't like multiply.
If it's a union. So if you have a situation where more than one branch has the outcome that you want, so you multiply along the branches, but then you would add the products that you got at the end of those branches. Like what I was talking to Libby about earlier, like let's say, I think we had an example similar to this on a homework assignment. Let's say we flip a coin and we go ahead and roll a die. Okay, so to make this easy, I'll just go ahead and say, let's roll the die first. Well, there's 6 possible outcomes, 1, 2, 3, 4, 5, 6, and then let's go ahead and flip the coin. Okay, so for each of these, no matter what comes up, I can either get a heads or tails. Heads or tails. Heads or tails. Heads or tails. We're almost there. Heads or tails. Heads or tails. Okay. So it's not the best looking tree diagram, but it kind of makes sense. So let's say that you're wanting to know what's the probability of, let's say, what was the one we talked about earlier, Libby? The one where I had that different outcome?
It was like 3 and heads.
3 and heads?
Wait, different outcome.
Yeah, there was 2 possible ways.
Oh.
Okay. Yeah, okay. So let's say to get a heads and a multiple of 2. Okay. The probability, and the wording is going to be very specific here. Because if you're looking for a multiple of 2 and a heads, you're just going to be looking for a branch. You're just going to be looking for the one branch where that can happen. Okay, but because all those are going to have the same probability, right? Okay, but if I were to say something like the probability of an even number or, what we say it, heads? Okay, then I'm going to be adding up those individual probabilities. So for example, to get all of these, they would just be 1/6, right? And then 1/2 for each of these. Okay, so an even or a head, well, we have this one right here. We have another even and a head right here, and then we have another even and a head right here. So each of these represents an intersection, right? So that would be 1/6 times 1/2, so that's 1/12. Okay, but this one also has an outcome that I want, so that's another 1/12. This one also has an outcome that I'm looking for. So see, multiple branches have what I'm wanting, so this is when I would add those individual probabilities. So that would give me 3/12, which is going to be 1/4. So I'd say there's about a 25% chance of rolling a even number and flipping a head. Is that help to clear it up a little bit? Okay. All right, good. How are we feeling about the homework? Has anybody actually got it done now that we did number 5? Good, good, good. Okay. Well, all right. If you do have any other questions, just let me know.